everyone, my name is Jing Yan. I'm gonna talk about the normal distribution today in this video. So, what is normal distribution and in what situation can the normal distribution be applied? So, in probability theory, the normal distribution is a very common continuous probabilities distribution. It's an important concept in statistics, and it helps us a lot when analyzing the cases in social and natural sciences. For example, when we are interested in the weight of people in a city, so we can just randomly select a sample of size n, measure their weight, record the results, and usually we draw a histogram and we can analyze the results. Other examples could be IQ test distributions, blood pressure distribution, or even the size of watermelons. So back to the weight example. The outcome experiment, which we usually call it the random variable X, is what we are gonna investigate. We know we will get different weight measurements, but when the sample size n increases and become large enough, there will be some trends. So now we look at this graph. These measurements will have an average around a certain value, which we call it the mean. Some measurements will be larger than the average value and some will be smaller, but they are clustering around that average value. As the article in the British Medical Journal Statistics Notes shows, which I also put the graph on the handout sheet, as the sample size increases, we expect the shape of the graph tends to be bell-shaped normal distribution, and it's usually denoted as in this form, n, the mean, mu, and sigma squared variance. With the application of confidence interval and z-table, we can estimate the range of population under different confidence significance levels. So here are the three most commonly used confidence intervals. So for example, we can say we are 95% confident that the population will fall on the range from the mean -2 standard deviations to the mean +2 standard deviations. Good, so what if the population itself doesn't really follow the normal distribution? So now I'm gonna introduce an important concept, the central limit theorem. Suppose a sample size n is selected from a population which doesn't necessarily follow normal distribution, that has mean, mu, and standard deviation sigma. Let x1, x2 to xn be the n observations that are independent and identically distributed. The central limit theorem states that the sample mean x bar follows approximately the normal distribution with mean, mu, and standard deviation sigma over square root of n. So the only condition it has is the sample size n must be larger than 30 if the population from where the sample is taken is not normal. So if the population itself really follows the normal distribution, then the condition is not a limitation. So here's an application. Let x be a random variable with mu equals to 10 and sigma to 4. A sample of size 100 is taken from the population. Find the probability of the sample mean of these 100 observations less than 9. So we notice that x doesn't really follow normal distribution in this question. So here's the solution. So we want to know the probability of x bar less than 9. So we transform the x bar to the standard z, and we want to know the probability of z less than -2.5. And now we can check the z-table, the standard normal probabilities table, to get the final result, which is 0.0062. Okay, thank you for visiting.